Okay, so in this lesson today, we're going to look at some of the properties of continuous random variables. And I'm going to link this back to discrete random variables and hopefully help you to see the connection and the similarities between the two. For discrete random variables, we were able to calculate the expectation and the variance like this. The expectation was the sum of x times its corresponding probability. So each probability was multiplied by x, and then we summed those all together. The variance was a combination of the expectation of x squared, a very similar calculation. We multiplied each probability by x squared, and then we summed those together. And then we subtracted the expectation of x squared. So this should be very familiar to you. How does that change when we're thinking of a continuous random variable? Well, it's actually very similar, but instead of the sum of discrete probabilities, we have to use integration of the function, and that's how we sum together our continuous probabilities. It's equivalent. So integration of the function is equivalent to the summation of the probabilities. So to find the expectation, we're going to multiply the function by x, and then we're going to integrate. To find the variance, I hope you can see and anticipate what's going to happen. We're going to multiply the function by x squared and integrate. That gives us the expectation of x squared. So now we need to subtract the expectation of x squared. Okay, so as we go through some examples, I'm sure you're going to see the running theme all the way through. Okay, so let's have a look at how we would actually calculate the expectation, the variance, and do a little bit of coding. So this function we've been given is 1/4 of x, and we're first asked to find the expectation. The expectation is going to be x times the function, and we're going to integrate in between the upper and the lower limit of the interval. So I can see already that I'm going to factorize out the constant of 1/4, and that's going to leave me with x squared on the inside to be integrated. So I'll get 1/4, and integrating gets me 1/3 of x cubed. I can actually factorize out the 1/3. I'll always do that. 1/12 x cubed, substituting in, we get 1/12 and 27 minus 1. That gives us 26/12, which cancels down, and as a decimal, we have 2.16 recurring. To find the variance, let's make sure we get both of these steps correct. To find the variance, we'll start with the expectation of x squared, and we'll find that by multiplying the function by x squared and integrating in between 3 and 1. So once again, I'll factorize out my quarter. This time round, we've got x cubed left to be integrated. Okay, so I've got 1/4 on the outside. Inside, I'm going to get 1/4 x to the power of 4. Factorize out the quarter. We've got 1/16 x to the power of 4, and we're working with limits 3 and 1. So 3 to the power of 4, 1 to the power of 4, hopefully you can do those both in your head. That's going to give us 81 minus 1. So the expectation of x squared is 80/16, which is just 5. A lot of students stop here and they think they found the variance, which is why I'm forcing you to think about the expectation of x squared first. And we know how to calculate the variance if we know both the expectation of x and the expectation of x squared. The variance of x is going to be the expectation of x squared minus the expectation of x squared. In this case, it's going to be 5 minus the 13/6 squared. And that leaves us with 11/36. Okay, the final two parts here are really asking us to do some expectation algebra, some coding with the expectations and the variance, which you should be really confident and comfortable with at this point in the course. The expectation of 2x minus 3 is 2 times the expectation of x minus 3. We'll substitute 13/6, and that gives us an answer of 4/3. The variance of 2x minus 3, we can always ignore adding and subtracting with the variance. So this is the same as the variance of 2x. We're going to bring out the coefficient of x and square it. So 2 squared variance of x, which is going to leave us with 4 times 11 over 36. 4 times 11 over 36 is 11 over 9. Okay, so let's just step that up, and you may have anticipated this. We're going to look at how do we do this when there are multiple functions involved with the continuous random variable. We're going to start off with exactly the same principles. I'm trying to integrate in between the lowest valid limit and the highest valid limit, and I'm going to integrate x times the function. So we're actually just going to do this for both of the functions and sum them together. So here I'm going to integrate. I'll factorize out the 2 over 15. I'm going to multiply x by another x. Here I'm going to factorize out the 1 over 5, and I'm going to multiply 5 minus x by x. So this is the integration that we need to process. For each of the functions, I'm multiplied by x, and I've applied the appropriate limits in between 3 and 0, in between 5 and 3. Okay, so I might just speed this up to go through. So you should really be able to process this yourself at this stage of the course, but I will walk you through exactly what I'm doing as well. So I've got 2 over 15, and when I integrate, I'm going to get 1/3 of x cubed, limits 3 and 0. I've got 1 over 5, and when I integrate, I get 5 over 2x squared minus 1/3 x cubed, and here's the limits 5 and 3. And as I substitute into here, we're going to get 9 minus 0. And substituting into this second function is going to have a lot more to do with it. I'll wait for the calculator to get my results here. Okay, so I've laid all this out. I need to make sure I show this to the examiner and for myself to look back through my work. And into the calculator, we get 8 over 3 for the expectation. Okay, so that's the first part of the question, to find the expectation of x. We still need to go on and find the variance of x. When finding the variance, we start with the expectation of x squared. If we start here, we're likely to get the answer correct. If we start here, we're likely to remember that there's still an extra step to calculate the variance. So the expectation of x squared, similar process, we're going to multiply each of the functions by x squared and process the integration. So the same factorization to simplify the integration that we actually have to process. This time round in the square brackets, I'm going to get 1/4 x to the power of 4, and I'm going to get 5 over 3x cubed minus 1/4 x to the power of 4. Okay, the first square bracket, once again, is a bit easier to factorize. The first square bracket is once again a bit easier to work with. I am going to factorize out the 1/4, and that will give me 1 over 30 on the outside, and then I'll just substitute 3 to the power of 4. We all know 3 to the power of 4, that's going to be 81. The second bracket, I'm going to set it up, but I'm going to rely on the calculator to process that. Okay, all into the calculator, we get a final answer of 49 over 6. A final answer, so that's going to be the expectation of x squared. One more step to go to calculate the variance. We know the variance of x is the expectation of x squared minus the expectation of x squared. Substituting in, 49 over 6 minus 8 over 3 squared gives us an answer, a final answer here for the variance of 19 over 8. Okay, this is a standard and a regular question that we're going to be asked to process. Can you find the expectation and the variance when there are multiple intervals, when there are multiple functions to define the continuous random variable?